All right, so this was a problem from the other day's homework. With everything that happened this week with me being out, I didn't get a good chance to go over it, so I'm going to go ahead and just do a video for this really quick. And first of all, I guess let's make this picture a little bit bigger so I can write all over it. So, when you look, it says a boat sailing due east, so we can see that the boat is actually traveling this way. And it gives me some information. It's traveling parallel to the shoreline. It's saying 10 miles per hour. I wonder if that's 10 miles per hour. I wonder if that's important. Seems like it might be. At a given time, the bearing to the lighthouse is south 70 degrees east. Okay, so that's why they put this right there. Got it. And 15 minutes later, quarter of an hour. Quarter hour. So how far did the boat go in a quarter of an hour? Well, quarter of an hour, 10 miles per hour, speed times time equals distance. So I'm really seeing that it went 2.5 miles. Now, I don't even know if that's helpful. I feel like it might be, but hey, whatever. And then it says the bearing is south 63 degrees east. Okay, so that's why they put this there. Got it. So most of the stuff is on there. It says find the distance from the boat to the shoreline if the lighthouse is at the shoreline. So find the distance from the boat to the shoreline. Distance from the boat to the shoreline. So I want to find that distance right there. I want to draw this down there. There we go. Got to find that distance. All right. So let's see. What do I know? Well, I see a big old triangle there. So, I do see a triangle there. As a matter of fact, I see lots of triangles. So I see a triangle here. I see a triangle here. Not there. Here. Oh, goodness. There. And then we've got this other one that's right in here. Right there. Okay. All right, so I'd love to know the length of that orange line. And I can see, maybe I should have made those non-orange. I can see I have this triangle. Or I can see that I have really this triangle. And either one of those would be great to find. But the trouble is, I don't have any information inside of them except for an angle. All I've got is an angle. And so, that's problematic. So I guess my goal is, I would love to be able to find one of those sides. One of the sides, any one in either the blue or the orange triangle would allow me to get the length that I want. And so I'm thinking that's a goal for me. The trouble is, the only place that I have any information whatsoever is right here. I know that's 2.5 miles. And that is in a triangle. Wow, that's a horrible, horrible triangle, but you get the idea. So I'm wondering if I can work inside of there. And if I look, those two diagonal sides are actually the sides of the other triangle that I was interested in. So I'm wondering if I can work inside of there. So let's go ahead and look at that. I'm going to just separate it out here. I do know that this, well, let's see, this is 63 degrees, and that's got to make a 90. So that really means that this angle here is 153. 63 and 90 together. What's more, I know that this is 70 right here, and this outside angle got to be the rest of the 90. So that means this one's got to be 20. And I know this is 2.5 miles. I have two angles inside of that triangle, so I can get the third. So 20 and 153 is 173. So that means that this has got to be the rest of the 180, or 7 degrees. Yeah, that's my 7. And so when I'm looking in this, I've got a whole bunch of angles. I've got one side. I could figure out either side that I want using the law of sine. So I'm going to go ahead and do that. I'm going to say the sine. No, I don't want to put sine on top. I want the side lengths on top because I'm looking for a side length. So over sine of 7 equals, my little degree mark there, x. I could find either. It doesn't really matter to me. So I'm just going to go ahead and, well, that 70 was in one of my right. Well, the 63 was too. It doesn't really matter. I'm going to choose. So I'm just going to call this x over the sine of 20 degrees. And what that means, when I work that out, I'm going to get x equals 7.016123 miles. Okay, all right, awesome. So I've got that. So the question is, where is that in my picture again? Let's go back. So I found x, which is right here. Maybe. Oh. Right there. And so I can see that if I'm looking for the distance to the shoreline, I can use, that's my x that I just found, and I know that this is 63. So, and I want to find this, which I'll call y. So I could really come over here and say that, well, that looks like cosine to me. Cosine of 63 equals y over x. So I could say x times cosine 63 equals y. And when I go ahead and multiply that out, I'm going to get that y, which is the distance to the shoreline, is 3.185 miles. And that is what I was looking for. Hope this helps. Have a good night.